Hello everyone, my name's Siva and my friend Azri. We gonna present about control force reducing devices used in aircraft. We'll be covering 5 important types: balance tab, anti-balance tab, servo tab, anti-servo tab, and there are 5 components and types of each elements. Balance tab, secondary flight control surface. Anti-balance tab, secondary control surface. Servo tab, secondary control surface. Anti-servo tab, secondary control surface used mainly with stabilators. Spring tab, secondary control surface with mechanical linkage. There are design and structure. For balance tab, a small hinged surface located on the trailing edge of a primary flight control like elevator or aileron. It moves in the opposite direction to the main control surface. Anti-balance tab attached to the trailing edge of an elevator or stabilator. Similar in appearance to a balance tab, but moves in the same direction as the primary surface.
A balance tab. The balance tab looks similar to a plain trim tab, but the balance tab's movement is linked with the movement of the control surface. This tab is useful on aircraft which do not have a hydraulic system which assists in the deflection of a control surface. When a control surface is deflected up, the tab will be deflected in the opposite direction or downward. The tab provides an additional aerodynamic force to hold the control surface in its required position and assists in the control surface deflection. So less force is required to move the control stick for movement of the control surface and makes flying the aircraft easier. Anti-servo tab. This tab is also used on small aircraft and also depends on the control surface deflection. But the difference between this tab and the balance tab is that this tab moves in the same direction as the control surface. This increases the feel on the control stick and prevents excessive movement of the control surface. This tab also prevents excessive stresses on the airframe structure and thus improving the aircraft's safety.
Hi, my name is Ahmad Nabil Azri, and now I will continue for the location of control force reducing devices. Control force reducing devices such as balance tabs, anti-balance tabs, servo tabs, anti-servo tabs, and spring tabs are all located on the same trailing edge of the main flight control surfaces. These include the elevator at the tailplane, the rudder on vertical stabilizer, and the aileron on the wings. Balance tabs and anti-balance tabs are most commonly found on the elevator, where they are help ease or control the force needed to pitch the aircraft up or down. Next, servo tabs are also typically installed on the elevator or rudder. Anti-servo tabs are commonly found on stabilators, which are all moving horizontal stabilizers seen on high-performance aircraft. These tabs help provide stability and prevent over-controlling at high speeds. Next, we got spring tabs. Spring tabs are often used on the aileron or elevators of larger or faster aircraft. Although small in size, these tabs are strategically placed to maximize mechanical and aerodynamic efficiency. Okay, next we got control input. Let's talk about how the control force reducing devices help with the pilot input. These tabs don't work like the main control surfaces. Instead of being moved directly by the pilot, they move in response to or with the control surfaces to reduce or adjust the control effort. First, we got balance tabs. Move opposite to the control surface to help the pilot. For example, when the elevator goes up, the balance tab goes down to make it easier to move. And next, we got anti-balance tabs. Move in the same direction as the surface, adding resistance for better control feel. And next, we got servo tabs, are special. The pilots move the tab, and the airflow moves the control surface, reducing effort. And next, anti-servo tabs. Move with the stabilators and add resistance, preventing over-controlling. And lastly, we got spring tabs, only activate at high speeds to assist pilot when aerodynamic forces become stronger. In fly-by-wire aircraft, these tabs are used less often, but in mechanical systems, they play a big role in helping pilots fly smoothly and safely. Next, we got configuration of control force reducing devices. Let's look at how different aircraft use control force reducing devices. In older or smaller aircraft, like general aviation planes, the pilot moves control surfaces such as elevators, rudders, and ailerons using mechanical linkage such as cables, rods, and pulleys. In larger and faster aircraft, like commercial airlines or military jets, control surfaces are bigger and heavier. These aircraft use hydraulic systems to move surfaces. In modern fly-by-wire aircraft like the Airbus A320 or Boeing 787, there are no mechanical linkage. Instead, pilot's input is sent electronically to computers, which control the surfaces. In these aircraft, control tabs are usually not needed to reduce the force. Some aircraft, like those with stabilators, full-moving horizontal tails, use anti-servo tabs. These add resistance when the surface moves, helping the pilot avoid over-controlling. So, the setup of these tabs depends on the aircraft size, speeds, and control systems. And finally, we got real-world applications and examples. In the real world, these devices are found on many aircraft. For example, the Douglas DC-9 uses servo tabs to control the elevators. The pilots only move the tab and the airflow does the rest. And last, we got older military aircraft like the Supermarine Spitfire and commercial jets, like the Boeing 727, uses spring tabs to help with the high-speed control.